Designing for high availability in mission-critical systems requires balancing between prevention and curative investment channels. While the system designer must always try to ensure that faults in both hardware and software happen as rarely as possible, he must also assume that faults will occur and take precautions to ensure that the system recovers quickly. For non-survival critical applications, the trade-offs are most often financial. Availability, that is, uptime, is expressed as a percentage of the time the system will be available over the total time of committed operations. While the organization may target for continual availability, the costs implied in implementing fault-tolerant and total redundancy to remove all single points of failure can be exorbitant. The correct trade-off between availability and recovery strategy is illustrated by the optimum designation. Beyond a certain level of uptime, the costs begin to increase at exponential rates. At a certain point, it becomes more cost-effective to invest in recovery strategies. That point will be determined by the extent of losses incurred by the line of business when outages happen. The analysis of the expanded incident lifecycle enables the total IT service downtime for any given incident to be broken down and mapped against the major stages through which all incidents progress, that is, the expanded life cycle. Availability management should work closely with incident management and problem management in the analysis of all incidents causing unavailability. Here's a cross-section in the life of a service covering the occurrence of 3 incidents. It illustrates when service was restored and the periods of service availability and unavailability. Availability management measures performance through several key performance indicators associated with the expanded incident life cycle. The mean time to restore service measures the average time over all incidents that it took to restore the service to its operational state. Mean time between service incidents measures the average time between the occurrence of service failures. The mean time between failures measures the average time between the restoration of a service and a subsequent failure, i.e., uptime. The expanded incident life cycle breaks down the period of service unavailability into categories of specific activities associated with the restoration of the service in an attempt to identify and localize poor performance practices that may be candidates for remedial process improvement. Tools should be exploited to provide automated failure detection, assist failure diagnosis, and support automated error recovery with scripted responses. While of use in all stages of the incident life cycle, tools can be indispensable in detecting events and incidents. Ideally, they are automatically detected and resolved before the users have noticed or have been impacted in any way. The use and capability of diagnostic tools and skills is critical to the speedy resolution of service issues. For certain failures, the capture of diagnostics may extend service downtime. However, the non-capture of the appropriate diagnostics creates and exposes the service to repeat failures. Where the time required to take diagnostics is considered excessive or varies from the target, a review should be instigated to identify if techniques and/or procedures can be streamlined to reduce the time required. Equally, the scope of the diagnostic data available for capture can be assessed to ensure only the diagnostic data considered essential is taken. The additional downtime required to capture diagnostics should be included in the recovery metrics documented for each IT component. Repair times for incidents should be continuously monitored and compared against targets agreed within operational level agreements, underpinning contracts, and other agreements. This is particularly important with respect to externally provided services and supplier performance. Wherever breaches are observed, techniques should be used to reduce or remove the breaches from similar incidents in the future. Backup and recovery requirements for the components underpinning a new IT service should be identified as early as possible within the design cycle. The outcome from this activity should be a documented set of recovery requirements that enables the development of appropriate recovery plans. To anticipate and prepare for performing recovery such that the reinstatement of service is effective and efficient requires the development and testing of appropriate recovery plans based on the documented recovery requirements. Wherever possible, the operational activities within the recovery plan should be automated. The testing of recovery plans also delivers approximate timings for recovery. These recovery metrics can be used to support the communication of estimated recovery of service and validate or enhance the component failure impact analysis documentation. Availability management must continuously seek and promote faster methods of recovery for all potential incidents. This can be achieved via a range of methods, including automated failure detected, automated recovery, more stringent escalation procedures, exploitation of new and faster recovery tools and techniques. Availability requirements should also contribute to determining what spare parts are kept within the definitive spares to facilitate quick and effective repairs. An incident can only be considered closed once service has been restored and normal business operations is resumed. It is important that the restored IT service is verified as working correctly as soon as service restoration is completed and before any technical staff involved in the incident are stood down. In the majority of cases, this is simply a case of getting confirmation from the affected users. However, the users for some services may be customers of the business, such as ATM services, internet-based services, for example. For these types of services, recommended that IT service verification procedures are developed to enable the IT service provider or organization to verify that a restored IT service is now working as expected. These could simply be visual checks of transaction throughput or user simulation scripts that validate the end-to-end service. IT availability or incident management measures the stages in this lifecycle performance bottlenecks and, on the basis of that analysis, may recommend service improvement initiatives.